Good morning, students. I am Dr. Monika Khetarpal, Associate Professor of Physics, Government Dungar College, Bikaner. Today I am going to teach you classical mechanics. This is the first paper in MSc Previous Physics. What is mechanics? Mechanics is the study of motion of physical bodies. Objects where can be small or large. Here, small objects can be of atomic size and the larger objects can be of celestial bodies shape. Their size can be of celestial bodies type. Now, I am going to discuss the conservation laws. What does conservation means? Conservation means some physical quantity may be constant with respect to time. Constant in time, here we are going to discuss the physical properties that are linear momentum, angular momentum, and energy. Initially, I am going to discuss the mechanics of a single particle. In the next lecture, we will be discussing the mechanics of number of particles. So, starting with the mechanics of a single particle. So, we are taking a single particle and I am going to derive the conservation laws of linear, angular, momentum and energy using the Newtonian mechanics. First is the conservation of linear momentum. Using the Newton's second law of motion, we know that F is equal to dp upon dt. Here F is the force and P is the linear momentum. When the total force acting on the particle is 0, that is F equal to 0. So putting F equal to 0, we get this equation as dp upon dt equal to 0. Integrating this equation, we will get P to be equal to constant. P is the linear momentum. As this equation is obtained by integration, so this law is also sometimes termed as first integral of equation of motion. This is derived by using Newton's second law of motion. Hence, when the force acting on the particle is 0, the linear momentum of the particle will be conserved, or we can say the linear momentum will be constant with respect to time. Now, moving over to the next law, which is the conservation of angular momentum. As we know, angular momentum is R cross P. Now, we are differentiating it with differentiating both sides. So, we get dl upon dt is equal to d upon dt R cross P. So, moving over to the next equation, we get by this equation using the cross product property. Here dr by dt is velocity, putting dr by dt to be v. This is dr by dt, putting it to be v. P is the linear momentum. And we know that linear momentum is mv. Here in the first term, we get v cross v. V cross v is 0. So this first term is equal to 0. Hence, dl upon dt, using Newton's second law in this part, we will get dl upon dt equal to r cross f. We know that r cross f, here this r cross f is torque, hence dl upon dt will be equal to torque. This is tau means torque. So rate of change of angular momentum is torque. This is Newton's second law of motion for rotational body. Here force is replaced by torque and linear momentum is replaced by angular momentum. Putting tau equal to 0, we get L equal to constant by integrating this expression. Hence, this conservation law is also termed as first integral of motion. Similarly, similar to the first, when F equal to 0, we get P to be constant. Here, similarly, we get when torque is 0, L will be constant. Now I am going to derive the third law of third law, that is conservation of energy. I am taking a particle which is initially at the position 1. Moving this particle to its final position 2, the work done by the particle will be, in moving from point 1 to 2, F dot dr, integrating it over to the total path 1 to 2, and further using the Newton's second law of motion, that is putting F equal to dp by dt, I get work from point 1 to 2 to be integral 1 to 2 dp upon dt dr. Here dr is the distance moved by the particle in time, which is having a velocity r dot. We know that linear momentum P is mv and v is written as r dot, and dr can be written as r dot dt as work done, which is expressed by this expression. Here I am putting the value of P and dr. P is written mr dot and dr is written r dot dt. So work done will be, using this expression, it will be expressed in terms of energy, which is the kinetic energy. Here T1 and T2 are the kinetic energy of the particle at the position 1 and 2. Now I am going to express this work in terms of potential energy. We know that force can also be expressed as minus del V, where V is the potential energy. Hence, work done in moving the particle from point 1 to the point 2 will be W12 integral, path is from 1 to 2 minus del V dot dr. Del V means differential of V with respect to R. So putting dV upon dr, we can get it to be, work done will be V1 minus V2. We have already obtained work done as T2 minus T1. Now I have obtained work done as V1 minus V2. So using both the expressions, equating both the expressions, because both have work done, we can get T2 plus V2 equal to T1 plus V1, which shows that total energy of the particle is conserved. Hence, we have derived all the three laws of the all the three laws of conservation, that is conservation of linear momentum, angular momentum, and energy. I hope you must have learned what I have taught today. These are the important laws of physics: conservation of linear momentum, angular momentum, and energy. So I am summarizing you what I have taught you today. Linear momentum will be conserved when force acting on the particle will be zero, and angular momentum will be conserved when torque of the particle is zero. And energy is conserved when the system is conservative in nature. Thank you, students. That's all for today.